The fifth term of an arithmetic sequence is 3. So a sub 5 is equal to 3. The 50th term, oh gosh, a sub 50 is equal to 30. Wow. Well, that tells you from the fifth term all the way to the 50th, we've only gone from 3 to 30. That means our common difference has got to be pretty small. It's going to be less than 1, isn't it? Okay. Find the sum, wait a minute, find the sum of the first 10 terms. So what are we going to do here? Well, writing out blanks isn't going to be good because I need to get from 5 to 50. There's not enough room. That's too many blanks to work out. So here's a couple of ideas. Here's the idea I like to do. So let's start with this. A sub 5 is equal to 3, and a sub 50 is equal to 30. Let me find the common difference. To get from 5 to 50, I'm going to have to add the common difference how many times? Well, from 5 to the 50th term, that's 45 times. 45 jumps, 45 blanks. So if I'm at 3 and I add the common difference 45 times, I should get to the 50th term, which I know is 30. So if I subtract 3, I get 27, and then divide by 45, I get my common difference. And that makes sense. It should be less than 1. We talked about that at the beginning. It's good to have a ballpark idea. 9 goes into both of those, so that's actually 3/5. So I've got my common difference is 3/5. Okay, now, the first 10 terms. Well, I know the fifth term. Now, let me give you a visual here. First, second, third, fourth, fifth, sixth, 7, 8, 9, 10. So here's your first term. Here's your fifth term. And here's your 10th term. Now I know the fifth term already. They gave that to me. That was 3. So I guess I could simply add 3/5 each time to fill in the blanks. I could get 3 and 3/5. And then I add 3, and then I'm going to get 3 and 6/5, so that's 4 and 1/5, etc., and keep going. And then I'm going to have to add all these together to come up with the sum. So maybe it would be nice if we had an easier way, or if we could figure out a general formula for getting the sum, then we could make this happen. Now, by the way, let's back up for a second. If we know the common difference is 3/5, let's switch to, how about blue? I know that a sub 5 is equal to a sub 1 plus 5 minus 1 times the common difference. And a sub 5 was 3. I don't know a sub 1. And I know the common difference was 3/5. So I can figure out the first term. It's going to be 3 minus 12/5. That'll be my first term. So that's 15/5 minus 12/5, which coincidentally is 3/5, the same as our common difference. So the first term is 3/5. And then we can just keep adding as we go. So I guess we could punch it out by hand, do a little crunching, but let's try and figure out a formula to get a series. Alright, the sum of a finite arithmetic sequence. So let's call this sum S sub n. It's going to equal the first term plus the second term plus the third term plus the fourth term, so all the way out, all the way to the nth term. Alright, maybe I'll say n minus first term and then nth term. Alright, so we're going to add all those together. Now, there's way too many variables here. So, using that formula, let me rewrite each of these. So let me say that S sub n, let's switch colors here. Let's say S sub n is going to equal a sub 1. Now what's a sub 2? Well, a sub 2 is equal to a sub 1 plus 2 minus 1 times d. Put that in parentheses. And then plus a sub 3. What's a sub 3? Well, a sub 3 is a sub 1 plus 3 minus 1, 2 times d. What's a sub 4? That's a sub 1 plus 4 minus 1 times d. Keep going. What's a sub n minus 1? Well, that's a sub 1 plus n minus 1 minus 1, so n minus 2 times d. And then the last one, what's a sub n? Well, a sub n is a sub 1 plus n minus 1 times d. Now you're thinking, where are we going? This seems even worse than what we had before. But at least now we only have 3 variables. We have a sub 1, we have n, and we have d. Okay, so now what I'm going to do, watch closely, it's going to get tricky. Now I'm going to write s sub n again, except I'm going to write it in reverse order. So I'm going to write this term first. So a sub 1 plus n minus 1 times d. And then I'm going to write this term next, a sub 1 plus n minus 2 times d. What would the next one be? It would be a sub 1 plus n minus 3 times d. And we keep going, and eventually we're going to get down to these last couple, and we're going to get a sub 1 plus 2d, and finally we'll get, oops, no, we got 3 more, a sub 1 plus 1d, and then lastly we have a sub 1. Okay, so now look what we have here. We have a giant mess. Yes, we do. So when you have a giant mess, what should you do? Let's add it all together. What's s sub n plus s sub n? Well, that's 2 s sub n's. All right, now let's add this first one here. Let's match all these up. So the first one here with the first one here. What do I get when I add those? Well, I'm going to get 2a sub 1 plus n minus 1 times d. Alright, now let's add the next two. We're going to add this quantity to this quantity. Well, we're going to get 2 a sub 1's again. A sub 1 plus a sub 1. So we get 2 a sub 1's. Now this is where you have to think. Now, what do we have? We have 1d plus n minus 2 d's. So how do we add those together? Think of it this way. What if I said add 3d plus 4d? What do you get? Obviously you get 7d, no problem, right? All you did was you added the coefficients 3 plus 4. Same idea here. Add the coefficients 1 plus n minus 2 times d. Well, that's going to simplify to n minus 1 times d. Wait a minute. Oops. Let's get rid of this. So n minus 1 times d goes right here. Okay, hey, that's the same as the first term we wrote. Alright, let's do the next two. So let's do this one. It's going to match up with this one. Those matched up. So they're all going to match up. So when I add these, I'm going to get, lo and behold, 2a sub 1 again. And then how many d's am I going to have? Well, I have 2 plus n minus 3. Well, that gives you n minus 1 again, times d. And it keeps going. Let's jump to the second from the end. That's going to match up with this one, second from the end. And we have 2a sub 1's. And then we have n minus 2 d's plus 1 more d. So n minus 2 plus 1 is n minus 1 d. And then we combine the last two terms here, and we get 2a sub 1 again plus n minus 1 times d. Alright, so we've got the same term over and over and over again. 2a sub 1 plus n minus 1 times d. 2a sub 1. How many of these are we going to have? Well, look up at the top here. We had 1, 2, 3, 4. We have n of those. So what we really have here is 2s sub n is going to equal n of these 2a sub 1 plus n minus 1 times d's. Now that looks a lot simpler. Now if I just divide by 2, I now have a formula for the nth, for the sum of the first n terms in an arithmetic sequence. And so now I don't have to, like in that last problem with those fractions, try and add all these things together. If I know n, and I know a sub 1, and I know the common difference, I've got my formula. So here you go. We have just generated this. We've proven it actually. S sub n is n over 2 times the quantity 2a sub 1 plus n minus 1 times d. Now this formula you'll see a lot in textbooks. Sometimes you'll see a variation. Look at this 2a sub 1. What if I split that up and wrote that as a sub 1 plus a sub 1? Now look what we have. And I highlighted in red what I want to focus on. When I split up this 2a sub 1, one of those a sub 1's plus the n minus 1d, does that look familiar? Yeah, that was our formula for a sub n, wasn't it? So this formula for s sub n, I could really replace the a sub 1, the red, stuff in red, I could replace that with a sub n. And so we have a second formula, which is actually the same as the other one. They represent the same thing. But two different formulas, and use whichever one you want. It kind of depends on what you have. The first formula, we need n, we need a sub 1, and we need d. For the second formula, we need n, a sub 1, and a sub n. We don't need d for the second formula. So I guess it depends on what the problem is giving you, decide which one you want to use. So now we can jump back to this problem that we were working on. That wasn't it. There it was. The fifth term of an arithmetic sequence is 3, and the 50th term is 30. So where were we at? We were trying to add up the first 10 terms. Well, what did we know? Well, we know that d was equal to 3/5. We know a sub 1 also wound up being equal to 3/5, just a coincidence. Now we didn't figure out a sub 10, although we could have, but I think that's all we need. And we know we're looking for the sum of the first 10 terms, so we know that n is equal to 10. So we've got everything we need. We have a sub 1, n, and d. So using that formula we just generated, s sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d, and we're ready to go. S sub 10 for this particular sequence is going to be n 10 over 2, 2 times a sub 1, which was 3/5, plus n minus 1, so 10 minus 1 is 9, times the common difference, which was also 3/5. And we work that out and we have our answer. So 10 divided by 2 is 5. We have 6/5 plus 27/5. So that's going to give us 33/5. 5 times 33/5, the 5's cancel, and we're going to get 33. And there we go. So now we can figure out any particular term, we can figure out common difference, we can figure out sum of terms for an arithmetic sequence.